Let's review your answers for the Unit 1 review. The first problem says Micah is attending a soccer game. He wants to determine which team has the most fans at the stadium. Circle the sample that would be best for Micah to use. The first sample says surveying the people who are attending from out of town, then surveying people who are wearing jerseys for the visiting team, then surveying the people sitting in the home team's fan club section, and finally surveying the people who are standing in line at the concession stand. Well, when we are doing a survey, we want to make sure that our survey best represents our entire population. When we're looking at what Micah wants to determine, he wants to determine which team has the most fans at the stadium. That means the population that he's looking at is all of the fans at the stadium. So everyone at the game or at the stadium. So we're looking for a sample where everyone at the stadium has an equal chance of being selected. So let's look at the first problem or first sample. This says surveying the people who are attending from out of town. Well, this would not be a good sample to use because not everyone at the stadium is going to be from out of town, so not everyone in the population would have a chance to be selected. Next, surveying people who are wearing jerseys for the visiting team. Well, again, not everybody would be wearing a jersey for the visiting team, so not everybody in the population had a chance to be selected, which means that's not a good sample. Then surveying the people sitting in the home team's fan club section. Well, not everybody in the stadium is going to be in the fan club section, so not everybody had a chance to be selected, which means that is not a good sample. Next, surveying the people who are standing in line at the concession stand. Now, for this sample, we know that not everyone at the stadium could get selected for this, but everyone at the stadium could be at the concession stand. So for these first three, these are very small parts of your population, and they're very specific parts of your population. But people standing in line at the concession stand could be from either team. So they could be from the home team or the away team, which means in this case, this is going to be the best sample to use. It still may not be the best sample to use out of all possible samples, but out of these choices, it is the best. Number 2 says Karen wants to determine how many students at her school have ever been injured while participating in extracurricular activities. So for this question, we see that her population is all of the students at her school because she wants to know how many students at her school. So the population here is all students at Karen's school. Now, she asks 15 students on the gymnastics team if they have injured themselves while playing sports, and 4 of them said yes. So the sample that she used was 15 students on the gymnastics team. Well, if I look at this and I know that I need to know something about all of the students at the school, but if I only ask the students on the gymnastic team, then not everybody in my school had a chance to be selected for that sample. And the students on the gymnastics team really do not represent everybody. So when you look at this, she said 4 of them said that they have been injured while playing sports or while participating in extracurricular activities. Well, people do get injured while playing gymnastics, but that's not the same as being on the art club or being in theater. So you don't necessarily have as much of a chance of getting injured on other extracurricular activities. So when we look at this, the sample that Karen used does not really represent the population that she wants to know about. So even though these numbers are probably correct, it doesn't matter because her sample was a bad sample to start with. So this is an invalid conclusion. And we're going to say that it's because Karen used a sample that does not represent the population. Now let's look at number 3. For number 3, it says the table below shows the lunch choices for 200 middle school students. So we see that we are looking at lunch choices and how many students chose each lunch. If there are 1,200 students in the middle school, so this would be our population, and this would be the results of our sample. Based on the table, about how many students would you expect to order salad and pizza? Well, let's look at salad. I know that 32 students in the sample chose salad, and that was out of 200 total people in the sample. And I want to compare that to 1,200 total students at the school. So I can make a proportion for this where I know that 32 students chose salad out of 200 students in the sample. And I can set that equal to, well, I don't know how many students are going to choose salad. So I'm going to put a variable here to represent how many will choose salad. Out of, I know that there are 1,200 total in the school, so I'm going to put 1,200 total in my population down here. Now to solve, there's a few different ways you can do this. You can recognize that to get from 200 to 1,200, we would multiply 200 times 6. So to get from 32 to x, you would multiply by 6. Or you could cross multiply. If you cross multiply, you would do 32 times 1,200, which would give us 38,400. And then you would put your equal sign. And then you would do x times 200, which would give us 200x. And then what you've done is create an equation. So on an equation, you want to get your variable by itself. And right now our variable is with 200. And it's being multiplied by 200. So to get the variable by itself, we would do the inverse operation. And the inverse of multiplying by 200 is dividing by 200. And so I would need to do this on both sides of my equation. Well, when I divide 38,400 by 200, I get 192. When I divide 200 by 200 over here, I get 1, so they cancel out because 1x leaves me with x. So I would expect about 192 students to choose salad. Now we can do the same thing with pizza. For pizza, I see that 59 students in the sample chose pizza, and again, that was out of 200 in the sample. So I'm going to say 59 chose pizza out of 200 in my sample. And I'm going to set that equal to, well, I don't know how many will choose pizza, but I know it's out of 1,200 total in my school. So again, you can look at this and say, I know that to get from 200 to 1,200, I would multiply 200 times 6. So to get from 59 to x, I would multiply 59 times 6. If you can't see that, then you can always cross multiply. So if I cross multiply, 59 times 1,200 is going to give me 70,800. And then I put my equal sign, and x times 200 gives me 200x. Then, to get my variable by itself, I'm going to do the inverse of multiplying by 200, which is dividing by 200, and I'm going to do that on both sides of my equation. Well, when I do 70,800 divided by 200, I get 354. Over here, when I get 200 divided by 200, those cancel to make 1x or just x. So this means that about 354 students will choose pizza. Now let's look at number 4. It says Duluth High School is considering adding a new sport to their after-school activities. Design a sample that you could use to help the administration determine which sport they should add. Well, when you're looking at this, you want to figure out who is your population. In this case, we want to know we can add a new sport too for Duluth High School. So we want to know about the students at Duluth High School. We want to know what sport they would want. So that means our population is all students at the high school. So for a sample, we would want a random sample, and that could be either a simple random sample where you're choosing maybe 50 random names off a list of student names, or a systematic random sample where you would be maybe surveying every 20th person who walks into school on Monday morning. So as long as your sample is a random sample, it is a valid sample to use. Now let's look at number 5. This data shows the survey result of 50 randomly selected students. So it shows their travel plans this summer, whether they are not traveling at all, traveling by plane, traveling by car, or traveling by train. And it tells how many chose each one. It tells us that if there are 600 total students, about how many would you expect to travel by car over the summer? So let's look at traveling by car in our table. Well, according to our table, 16 students say that they will travel by car. And that's out of 50 students who were surveyed. So to make a proportion for this, I know that 16 are going to travel by car out of 50 in my sample. And I know that there are 600 students at the school. What I don't know is how many will travel by car, so I'll put an X here for car. And I know that this is 600 here. Now you can recognize that 50 times 12 would give me 600. So to get from 16 to X, you would multiply 16 times 12. If you can't recognize that, that's fine. You can cross multiply. So 16 times 600 would give us 9,600. And X times 50 would give us 50X. And then to solve, you would divide by 50 on both sides of your equation. And 9,600 divided by 50 would give us 192. And 50 divided by 50 gives us X. So what I would say for this is that about 192 students will travel by car. Now let's look at page 13. So everybody flip to page 13. For this part, we're going to look at measures of center and spread. Number 6 says Megan and Julio are both on a basketball team, and below are the number of points each of them scored over the past 5 days. It says how much higher is Megan's median number of points than Julio's median number of points. So that means that we need to find both of their medians. Remember that before we can find a median, we have to order our data sets from least to greatest. And if you noticed, neither of their data sets are ordered right now. So the first thing we should do is order them from least to greatest. So for Megan, we have it 6, 9, 11, 12, 13. For Julio, we have 6, 7, 8, 9, 10. Now we need to find their medians. So we would cross out one number from the front and one from the back until we get to the middle. So front and back. And then Megan's median is 11. We're going to do the same thing for Julio. So one from the front and one from the back, front, back, until we get to the middle, and his median is 8. When it asks how much higher is Megan's median, that means I need to find the distance between Megan's median and Julio's median, so I would subtract. So I would do 11 minus 8 equals 3. Now let's look at number 7. It says Karen and Dave's humanities test scores are shown below. And my first question asks, who typically has higher test scores and which measures tell you this? Well, we know that when we're looking for typical behavior, we're looking at mean and median because we're looking at those measures of center. So let's find those for both Kara and Dave. So for Kara, her mean would be adding up all of these scores. So 84 plus 92 plus 88 plus 86 plus 95. And when we do that, we get 445. Well, we know we need to divide that by 5 since there are 5 test scores. And when we divide by 5, we get a mean of 89. Now we need to find Dave's mean. So for Dave's mean, we would add 72 plus 85 plus 91 plus 88 plus 90. When we add all of those, we get 426. And again, we need to divide by 5 since there are 5 test scores. When we divide this by 5, we get 85.2. Now looking at the mean, it looks like Kara has a larger mean, so I would say she typically has higher test scores. So I'm going to say Kara's mean is greater. So her test scores are typically higher. Now let's look at the next part. It says both Dave and Kara get a 98 on their next humanities test. Who will see a greater increase in their overall humanities grade? So if we go back to their list, this is like saying that both of them have another test score here at the end and it's 98. Well, we know overall grades are averages of grades. So we need to look at what Kara's new average or mean is with the 98 and what Dave's new average or mean is with the 98. So let's look at Kara. So Kara's new mean, we would add 84 plus 92 plus 88 plus 86 plus 95 plus 98. So when we add all of those, we're going to get 543. And we need to divide that by 6 now because now there are 6 test scores. When we divide 543 by 6, we get 90.5. Well, let's compare that to Kara's old mean. So before she got the 98 added to her test scores, her old mean was 89. So let's look at the difference or the increase in her grade. Her old grade was 89 and her new grade was 90.5. So to figure out how much that increased, let's subtract. 90.5 minus 89 is 1.5. So Kara's grade increased by 1.5. Now let's look at Dave. So let's find Dave's new mean. So now for Dave, we're going to add 72 plus 85 plus 91 plus 88 plus 90 plus 98. Well, when we add all of those together for Dave, that is a new total of 524. And we're going to divide this one by 6 because now there are 6 test scores. Well, for this, we get 87.3 repeating, but if we round this to the nearest 10th place, that's 87.3. Now let's compare that to his old mean. So Dave's old mean was 85.2. So to figure out how much his grade increased, we're going to figure out the difference between his old mean and his new mean. So he started out with 85.2 and ended with 87.3. So the difference between those when we subtract is 2.1. So let's look at what that means. Kara's grade increased 1.5 points and Dave's grade increased 2.1 points. So the person that had the greater increase is Dave. So we're going to say Dave had the greater increase. Now let's look at part 3, which is talking about box plots and dot plots. For number 8, Miss Kelly asks each of her students to tell her the number of problems they completed for homework last night, and she records their results using this box plot. Then it says Miss Kelly asks her students to each add 5 to the number that they told her before. What will the new box plot look like? Well, the new box plot, if you think about it, will be exactly the same, except it will be moved 5 units to the right, because the student that chose the lowest number of problems last night was 2. Well, if Miss Kelly tells all students to add 5, then that student now is going to be 2 plus 5, which is at 7. So the new box plot's least value will be here. The first quartile before was right here at 3, but now that's going to be 3 plus 5. So the new first quartile is going to be right here at 8. The old median was at 6, so the new median will be 6 plus 5, which is 11. The old third quartile was at 8, so the new third quartile will be 8 plus 5, which would be over here at 13. And then the old greatest number was 10, and the new greatest number will be 10 plus 5, so that would be over here at about 15. So this box plot would look exactly the same with the same interquartile range and the same range, except everything is moved 5 spaces to the right. So we can say that this would be translated 5 places to the right. The median would be 5 numbers greater than the original median. All right, for number 9, it says the box plot below shows the test scores of 2 different math classes. Compare the medians, ranges, and interquartile ranges. Well, if I compare the medians, I can see that my second period has a greater median than first period. So I would say second period has a greater median. Which would tell me that second period typically performs better on tests. I also see that for range, my first period has a greater range because it goes here to here, and second period only goes from here to here. So first period has a greater range, and it also has a greater interquartile range, which I can tell because the box is larger for first period. So first period has a greater range and interquartile range. Well, those are both measures of spread. Since first period has greater measures of spread, that means that they're actually less consistent because their scores are much more spread out. So first period is less consistent than second period. Now let's go to page 14. On page 14, number 10 says the box plots below show the average gymnastics scores given by 2 different judges. What percentage of scores given by both judges was above 7.75? So we need to find 7.75. If I'm looking on my number line, I would say this would be about 7.5, and 7.75 is about 7 3/4. So that would be 1, 2, 3. So that would be about here. So I can see that this is the point that I'm looking at for both judges. Well, for the 2010 game, I can see that I have 1 section, 2 sections, and then 3 sections. And I know that each section is worth 25%. So that means greater than 7.75 for 2010. That is 75% of the scores were greater than 7.75. Now let's look at 2006. So again, here's 7.75. Now this is 1, 2, 3 sections. So that is again 75% of scores that are greater than 7.75. Now let's look at our last problem, number 11. The dot plot below shows the number of hours that students in Miss Scott's class spent exercising and playing video games over the past week. So let's compare them. First thing I want to compare is the least number of hours that both of them chose. Well, for exercise, the least number of hours was 0. And for video games, the least number of hours were 0. So those are the same. So to compare, I would say both are 0. Now let's find the median number of hours. So we need to find the median for video games and the median for exercise. Well, we're going to find the number in the middle. What we notice for this is that we have two numbers in the middle. So for exercise, the two numbers that are in the middle are 2 and 3. Well, we would have to add those together and divide by 2. So 2 plus 3 is 5, and 5 divided by 2 is 2.5. So for exercise, the median is 2.5. Now for video games, I'm going to go to video games and find the number in the middle. Well, what I noticed for video games is that there are also two numbers in the middle, but this time both of the numbers are 9. So I would do 9 plus 9, which is 18, and then divide by 2, which would give me a median of 9. So I would say video games has a greater median. All right, for the mode, I can see that for exercise, the mode is 0 and 2 because those are my two highest. So for exercise, the mode is 0 and 2. For video games, I have several highest. I have 6, 8, 9, 11, and 12. So it's going to be 6, 8, 9, 11, and 12. Now for the range. For exercise, the largest data point is right here at 12, and the least data point is right here at 0. So 12 minus 0 gives us a range of 12. For video games, my greatest data point is right here at 14, and my least is right here at 0. So my range is 14 minus 0, which is 14. So whose range was greatest? Well, the range that was greatest was video games, which tells us that that is least consistent. Based on the data, would you expect people to spend more time exercising or more time playing video games, and why? Well, let's look at the median, because the median is my measure of center that would tell me this. Well, I see that exercise has a median of 2.5 and video games has a median of 9. Because video games has a greater measure of center, that tells me that typically students spend more time playing video games. So we would say video games, and the reason is because the median is higher.